Welcome to this brand new solution video. You can treat this as a marking scheme as well because the official marking scheme is not out yet. So let's get started. Question number 1. The coefficient of x to the power 4 in the expansion of this is equal to the coefficient of x square in the expansion of this. They are equal. That means there are two situations. Let's work on them separately and then we'll club them. So coefficient of x to the power 4, this is what we need here in 3 plus x to the power 5. Alright, since it is just a single x and 3, we can straight away do this. For finding x to the power 4, the x part of the binomial should have a power 4. That means out of 5, 3 will have the remaining power, which is just 1. And before this, we write NCR, which is N is 5, total number is 5, C and R is any of these two numbers, 4 or 1. I'm writing 4. So 5C4 is 5 and times 3 and then x4. I'm writing them in this order so that I can write that the coefficient of x to the power 4 is 15 in this case. Let's expand this one. This will challenge us a little where we want a coefficient of x square. So coefficient of x square we need. And this is not straightforward as this 3 plus x it was. It is 2x over a plus x. That means some power of this will cancel out some power of the denominator. And let's work out what can do that. Let's start with the 3. Let's give both of them 3 and 3. 2x to the power 3, even 2 is not needed. I am interested in x. And a over x to the power 3. So I'm not writing a because I'm interested in just x's. So x cube and 1 over x cube, they will cancel out. So we are not getting x squared. That means we need this one more than this. So let's try x to the power 4 over x to the power 1 over x to the power 2, right? 4 plus 2 is 6. That's what we need, 6 total. And yes, if we cancel x square with x to the power 4, we get x squared. So yes, we need x to the power 4. So let's do it. 2x to the power 4 multiplied by a over x to the power 2. And then we write NCR, which is 6 in this case. N is 6 and C 4. Okay. So now 6C4 is 15, 2 to the power 4 is 16, and x to the power 4, then a square over x square. This is the expansion, and now as expected we will cancel this one. It will become x square here. So what do we get here? 15 times 16 will be 240. A square x square. So they said coefficient of x4 in this case is equal to the coefficient of x square in the second one. So coefficient of x4 is 15 in this case is equal to 240 a square, which is the coefficient of x square in this case. So let's divide both of them by 15, rather 240 rather. 240. Let's divide both of them by 240 so that this goes and it again 16. Yeah. So a square is 1 over 16, and to find a we'll have to square root this. We'll get plus and minus 1/4. But they say find the value of the positive constant a. Positive we want. So finally positive 1/4 is the right answer. Negative will be ignored. Let's move on to the second question, which is the second and third terms of a geometric progression GP are 10 and 8. All right, first and second. No, second and third. A2 is 10 and A3 is 8. Find the sum to infinity. So sum to infinity is a over 1 minus r. So we have to find the first term as well as common ratio. Common ratio R is equal to any term divided by previous term. So we can write A3 divided by A2, which are given to us, right? So A3 is 8 divided by A2, which is 10, and we can simplify it to 4 over 5. This is R. Alright, now we need the first term. So R can also be written as A2 over A1, correct? And we need this A is actually A1. So R we know now, so we can write 4 over 5 equal to A2 is given to us 10 over A1. So cross multiply, it gives us A1 equal to 10 times 5 divided by 4. This is 2 and 5. 25 over 2, which is 12.5. This is the first term. And now we can find S infinity, since we know this is 12.5 over 1 minus, and 4/5 is R, right? We can write it equal to 0.8. Yeah, so 12.5 divided by 0.2 will be 62.5. This is sum to infinity. Okay, what's in question number 3? The equation of the curve is such that the differentiation of that curve is equal to this. It is given that the curve passes through this point. That means when x is 4, y is 5 over 2. Find the equation of the curve. So if the differentiation is given, we can first of all rearrange this. Okay, we can. So dy I keep here, and dx goes with 3. Let's write whole here. 4x minus 7 to the power half minus 4x to the power minus half and times dx. Now we will integrate the left side with respect to y and right side with respect to x. We can do that. We can integrate them with different variables. So it becomes y, and if we integrate this separately, so 3 is a constant, untouched. What are we left with? 4x minus 7. It is a linear part, so it is we can write half plus 1 divided by half plus 1. Okay, we can do this in case if it is a linear, and if it is not linear, then we'll have to do something additional. So since we are integrating, we will divide it by the differentiation, not integration, differentiation of what is inside, which is 4x minus 7, and its differentiation is just 4. So this is what we are left with, and this will be minus 4 is constant again, x to the power again linear, half plus 1 over minus half plus 1. And because 4 does not has this exponent, so we are not involving it as the power. So if we differentiate x, it is just 1, so there is no point in multiplying by 1 here. If we do, that is not wrong, but there is no point. Okay, plus c. So what do we get? Y equal to, and this is half plus 1 is 3 over 2. So let's write 4x minus 7, 3 over 2, and denominator is also 3 over 2, but I will add just 3 here, and 2 I will multiply with the numerator. That's the rule. Denominator of denominator is numerator, just like enemy of an enemy is a friend. So just like that. Kidding, it is just an analogy, okay? Don't take it seriously. So 3 and 3 cancel, 2 and 4 cancel. All right, so minus, and here we get positive half as exponent here, so half will be 1 over 2, same way. And if I reform this one, I get everything cancelled here, so we are left just with half 4x minus 7 to the power 3 over 2 minus, okay, this is positive half, 2 times 4 will be 8, so 8, and x to the power half can be written as square root x plus c. But this equation is not complete until we get the value of c, and for that they have given this information. The point 4 and 5 over 2 lies on this curve, so that means y will be replaced by this, y will be replaced by 5 over 2 equal to half 4 times 4, x is 4, 16 minus 7 to the power 3 over 2 minus 8 square root 4 plus c. So let's keep c on the right side and bring everything to the left side. 5 over 2 is 5 over 2, then this becomes what? 16 minus 7 is 9, and 9 to the power 3 over 2 will be 27. Please use calculator if you don't understand what happened here. So minus 27 over 2. That's what this whole thing become, because it's positive, so I made it negative when I brought it to left. Now this will be 8 times 2, 16, positive 16 equal to c. So 27 minus 5, minus 22 over 2, minus 11 plus 6. So minus 11 plus 16, not 6, 16 equal to c, and c is equal to 5. So now our equation of the curve is ready. That was the equation, y equal to, this was it, half 4x minus 7 to the power 3 over 2 minus 8 square root x, and now we have c 5. That is the final equation of the curve. Okie dokie, next one. Okay, too much space for this. The first, second, and third terms of an arithmetic program, this time AP, are k, 6k, and k plus 6 respectively. Find the value of the constant k. So we know that the common difference d is any term minus previous term. So a2 minus a1 will be d. Same will be the third term minus second term, isn't it? And what do we have? We have a1 equal to k, a2 equal to 6k, and a3 equal to k plus 6. So we'll substitute them here now. a2 is 6k minus k equal to k plus 6 minus 6k. Let's collect all the k's here. 6k minus k plus 6k equal to just 6. This is the only number, right? Plus 6k. All right. So 6 plus 6, 12k, minus 2k equal to 6, which is 10k. So k will be equal to 6 out of 10. Or you can write this as 3/5 by simplification, or 0.6. That is the value of k. This must have a b part also, which is here. Find the sum of first 30 terms of the progression. So first 30 terms, so we have the formula for number of terms. Sum of them is this. You get this in your formula sheet, so don't worry about this. So S30 will be 30 over 2 over 2a. We have a as k, and k's value we just got 0.6. Plus n minus 1, which is 30 minus 1 in this case, d. So do we have d? Let's find d. All right. D was a2 minus a1, which is 6k minus k. Let's use d through this. So d equal to 6 times k minus k. I'm sorry, it is 6 and 6. Yeah, so it will be 3.6 minus 0.6, that comes out to be 3. D is 3. All right, so let's use it here. So 30 divided by 2 is 15. 2 times 0.26 is 1.2. 29 times 3 is 87. So we get 15 times 88.2, which is 1300. Okay, looks like a decimal here. 1323. That is the sum of first 30 terms. Let's go to the next one. The equation of a curve is given. All right. And the equation of a line is also given. Perfect. Where K and A are constants. So K is here, here, and A is here. Okay. Given that the curve and the line intersect at points with x coordinates 0 and 3 or 4, find the values of K and A. So let's try to visualize this. Suppose this is the curve and this is the line. The x coordinate of this one, which one is more? 3/4, is 3/4. And the x coordinate of this one is 0. Doesn't that mean that both line and curve, both of them will satisfy the equation with these two x's? Let's try to do that. So y is equal to, if I substitute 0 in this equation, okay, which will be equal to 4 times 0 square minus k times 0 plus half k square. In this is when x is 0. For line, we will get y equal to 0 minus a, right? So since both of them have same y, because this is the common point, and the y code, whatever is y, if this is x-axis, whatever is y, it is same for both line and the curve, we'll equate them. So 4, 0 square is 0, k times 0 is 0, so half k square equal to minus a from the second side. Yeah, so let's write that a is equal to minus half k square. Okay, so we'll substitute this a in the second equation we are going to get. This is the equation number 1. All right, now we'll substitute 3/4. So 4 multiplied by 3/4 square minus k times 3/4 plus half k square, same half k square, okay, is equal to, now I will substitute here also 3/4 minus a, minus a. And now in place of this a, can I write minus half k square again? So in place of this a, our minus is already there, and I will write minus half k square in place of that a, right? And now we'll open this. This becomes 9 over 16. So 9 times 4. Or rather we can, okay, I'm not using mental math here. Let's see it. 36 over 16. This is what it will be. Minus 3 over 4k plus half k square and equal to 3 over 4 plus half k square. Since both of them have half k square, we can subtract half k square from both sides and they are gone. All right. So what is the simplified form of this one? If I simplify this, it will become 9 over 4. 9 over 4 minus 3 over 4k equal to 3 over 4. So minus 3 over 4k we can keep here. And here we get 3 over 4 minus 9 over 4. All right. So minus 3 over 4k equal to minus 3 minus 9 6 over 4. Both of them have 4, so we can cancel denominators 4 by multiplying 4 both sides. Negative and negative can also cancel. So 3k equal to 6. So k equal to 6 divided by 3, which is 2. And in question, they had asked to find both k and a. We have to find a also. So we can use this formula for finding a. A equal to minus half k square. K is 2. So just put 2 square here. So 4 divided by 2 is 2. A equal to minus 2. That's how we've got both k and a. Alright, what's the second part saying? Given that a is minus 7 over 2, so it's a different situation. Instead, they're saying find the values of k for which the line is a tangent to the curve. So line is not crossing the curve, it is tangent to the curve. That means they have just one point in common. So if I equate the two equations, I'll get just one solution. So 4x square minus kx plus half k square. 4x square minus kx plus half k square is equal to x minus a. And now they've given a is minus 7 over 2. So in place of this minus a, I will write minus 7 over 2. So what does this quadratic equation become now? 4x square will be here. Kx minus kx is the only x. No, this is also here. So minus kx minus x. This x also comes to the left. Plus half k square and minus 7 over 2 equal to 0, because this negative and this negative makes it positive, but when we bring it across the equal sign, it becomes negative 7 over 2. So let's try to take this common here. So 4x square minus k plus 1 x, okay, plus half k square minus 7 over 2 equal to 0. Now, since we know that there is only one solution of this quadratic expression, for one solution we know that the discriminant b square minus 4ac has to be equal to 0. So that means b is this for us, minus k plus 1. This is b. Square minus 4 times 4, and c is this half k square minus 7 over 2. This has to be equal to 0. A new quadratic equation will be formed. So let's square this. Because of this square, this minus will become positive. So we will just square k plus 1, which will be k square plus 1 plus 2k. Then we have minus 16 times half, which is 8k square. Then minus 16 times minus 7 over 2 plus. So 16 times 7 over 2, 56, equal to 0. And in simpler form, it becomes k square minus 8k square minus 7k square plus 2k plus 57 equal to 0. And now you can find k by using your calculator. I'm just going to factor this. 7k square, and it will be 19, 21. 21k minus 19k plus 57 equal to 0. Minus 7k taken common here. K minus 3 minus 19 is taken common. K minus 3 equal to 0. So I get minus 7k minus 19 and k minus 3 equal to 0. So we get two answers. One, minus 7k minus 19 equal to 0, which is minus 7k equal to 19, k equal to negative 19 over 7. And second is k minus 3 is equal to 0, so k becomes equal to 3. These are the two answers, and I hope they have not given any filter in the question. Find the value of k for which the line segment is a tangent to the curve. So k has two values for which it is a tangent. Next question, please. Alright, here we have a drawing. And the diagram shows the curve of equation this one, okay. A line of the equation this, they are crossing each other. Find the exact area of the shaded region which is bound by the line and the curve. So before we proceed, let's plan this. If somehow I find this point and this point where the shaded region is starting and finishing, right? And find the area under this curve, which will be this whole area, right? Out of this whole area, if I remove this white part, which is a trapezium, isn't it? This line, this and this will be a trapezium. So if I remove this trapezium, we'll get a shaded area. There's no B part, that means this is the only question with this. So let's try to find these 2 points, which are the points of intersection of these two equations. And just like in previous question we will equate them. So 2x plus 2 is equal to 5x to the power half. Okay, let's bring this to the other side. So it becomes 2x minus 5x to the power half plus 2 equal to 0. This is your abnormal kind of quadratic equation. So we'll do what? We'll take x to the power half as another variable, say t. So if I square this and square this, x is equal to t square. So that's what I will do here now. 2t square minus 5t plus 2 equal to 0, and now it's a perfect quadratic equation which we can easily factorize. So 2t square minus 4t minus t plus 2 equal to 0. So we take 2t common here. T minus 2 minus 1, t minus 2 equal to 0. So the two factors are 2t minus 1 and t minus 2 equal to 0. And just like previous question again, it's a quadratic equation, so we'll get two solutions. First one, let me write here. 2t minus 1 equal to 0, which gives us 2t equal to 1, and then t is equal to 1 over 2. But t was our creation. It was actually x to the power half. So that means x to the power half equal to half. So we'll have to square it to get a value of x. So x is 1/4. So the x coordinate of this first point is 1/4. And have they named it? No. So let's name it. A 1/4 is its x coordinate. Since we have found x coordinate, let's find y coordinate also. So the y coordinate for this, just substitute in any of the two equations. Let's say 5 squared x. 5, and we have x now. X is 1/4. So 1/4 to the power half. So 5 times half, positive half. Why? Because negative is somewhere else and we know it is positive. Definitely y value is positive, so I'm ignoring the negative while square rooting. It is 5 over 2. So we got the y coordinate also, which is 5 over 2. Now we had one more solution from the factoring we did. Okay, This was t equal to 2. So in that case, x to the power half is 2, and again square root, both sides, x equal to 4. So the x coordinate of second point, B, let's call it B, is 4. And we have to find y also. Let's do it. This time I'm using this. So it's not a rule that you have to use the same equation again. You can use any one of them because they are intersecting. Both of them will give you the same answer. So y will be 2 times 4 plus 2, which is 10. So the y coordinate is 10. It will be useful when we will find the areas. So good, done. So now we know both the points. Now we can find the area of the trapezium. So area of trapezium is half first parallel line plus second parallel line times height, correct? That's what we'll do here. Half first parallel line is this. Let's take this shorter line, which is the y coordinate of point A. That's the length, 5 over 2. And the second one is this line, which is the y coordinate of B. And height is the distance between the two parallel lines, which is 4. This is 4. This is 1/4. 4 minus 1/4. So 16 minus 1, 15 over 4. So it becomes half times 25 over 2, 15 over 4. So how much is that? 2 times 4 is 16. 4 times 16, yes. And 25 times 15 will be 375 units square. That is the area of this white trapezium. Now we'll have to find the area under the curve and subtract this area from that area. So let's find the area under the curve, 5x to the power half. And for that we'll have to integrate it. So area under curve equal to integration of 5x to the power half dx from 1/4 to 4. That's what we need. So the integration is 5x to the power half plus 1 over half plus 1. We have done this earlier in one of the questions, so no big deal. And 1/4 to 4. So it comes out to be 5x to the power 3 over 2, 3 over 2 plus c 1/4 till 4th. And now let's substitute numbers one by one. 2 times 5 becomes 10. So 10 and then 4 to the power 3 over 2 over 3 plus c minus 10 times 1/4 to the power 3 over 2 over 3 plus c. C and c cancel out. Okay. So what are we left with? 4 to the power 3 over 2 will be 8. So 80 over 3 minus 1/4 to the power will be 3 over 2, 1 over 8. So it will be 10 over 24. I'm doing everything mentally. Please use your calculator if you are not sure how I got this one. Okay, so we can multiply this by 8 to make it 24. So this comes 640 minus 10, 630 over 24. This is the area under the curve. And now we have to find the area of shaded region. That's what our plan was. From this area we just got, we will subtract the previous area that we got, which is they're saying exact area. Can you see? We subtract 375 over 16. 375 over 16. For that I'll need to use my calculator, and by the time I use my calculator, please subscribe to my channel, like and share this video, share with your friends, and I will be motivated to even more videos like this. Alright, I got 45 over 16 units square, which cannot be simplified further. This is the area. Moving on, number 7. The diagram shows a sector OBAC. You can see that with center O, radius 10. The point P lies on OC, right? Is perpendicular to OC, yeah. Angle AOC is 1 over 6 pi. It's here, and length of AB is 2 centimeter arc. Find the angle BOC. BOC, which includes 1 over 6 pi. So actually they are asking us to find this and then add pi by 6 to this. So we know that arc is equal to R multiplied with the angle it is subtending at center. So arc is 2 centimeter for this angle. So 2 equal to radius is 10 centimeter, and theta we have to find out. So divide both sides by 10, and this becomes 1 over 5. Theta is 1 over 5 radians. Okay, but they were asking angle BOC, which will be 1 over 6 pi plus 1 over 5, which is this one. Total is this angle. They have not said whether it has to be an exact or decimal. If you want to express this in decimal, it is equal to 0.7235598, and 3 significant figures will be 0.724. Let's go to the next part. Hence, find the area of the shaded region BPC, giving your answer correct to 3 significant figures. Okay, so we need the area of this shaded part. The plan is that I will find the area of this whole sector. So area of the sector minus the area of this triangle BPO, this triangle, area of the triangle. Okay, so let's find the area of sector first. Area of sector is half theta and r square. So half is half theta. For this whole sector, the angle is 1 over 6 pi and times 1 plus 1/5. So let's write this 0.724 here. 0.724 multiplied by r square. We know the radius given is 10. So 10 squared. So 100 divided by 2 is 50 times 0.724. Okay, so it is going to be how much? 36.2 centimeter square. That is the area of the whole sector. Now next job is to find the area of triangle. And area of triangle is half base times height. In this triangle, OP is base, B is OP, and height will be BP. Now, let's try to find them one by one. First, let's say OP. So we can say that OP, this is OP, divided by 10 will be cos and this angle, isn't it? So let's do that. OP divided by 10 equal to cos 0.724. Similarly, BP divided by 10 will be sine 0.724. So if I cross multiply in both cases, OP comes out to be 10 cos 0.724 and BP will be 10 sine 0.724. So now we can use the formula here because we know base and height both. So half base is OP, 10 sine 0.724 multiplied by height, 10 sine. No, that is not sine. This was cos, right? Base, it doesn't matter which we write first. Okay, it's commutative property. So let me write cos here. Okay, done. And now we just have to write the answer by putting this in a calculator. And by the time I do this, I would request you to subscribe to my channel, share this video with your friends, like it, and motivate me to make even more videos like this. 24.8 approximately. So this is the area we have to subtract from the area of the sector. Area of the sector was 36.2. And now we've got 24.8 area of triangle. Subtract this and we get 11.4 centimeters squared. This is the area of the shaded part. Okay, the next question. The equation of a circle is given here, okay, and the points 1, 1 and 2 minus 6, they lie on that circle. So let's draw the circle. This is the circle, okay. There's a point on it which is 1, 1 and second point is 2 minus 6. Okay, find the values of A and B and hence find the coordinates of the center of the circle. Okay, so suppose this is the center and this is the equation. X square plus y square plus ax plus by minus 12 equal to 0. To find the values of a and b, we will substitute these 2 points into this equation and we'll get 2 simultaneous equations and then we can find a and b. So let's substitute 1 and 1. 1 square plus 1 square plus a1 plus b1 minus 12 equal to 0. 1 plus 1 is 2. 2 minus 12 minus 10 plus a plus b equal to 0. So it gives us a plus b equals to 10. This is equation number 1. Let's substitute 2 minus 6 now. So 2 square plus minus 6 square plus 2a minus 6y, not y, b. 6b minus 12 equal to 0. So it becomes 4 plus 36 plus 2a minus 6b minus 12 equal to 0, and that gives us what? 4 plus 36 is 40. 40 minus 12 is 28 plus 2a minus 6b equal to 0. So this gives us equation 2a minus 6b equal to minus 28. Now let's use elimination method to find a and b. We will multiply this equation by minus 2. So let's write out of this here minus 2a minus 2b equal to minus 20. And now we can add. Many people subtract after multiplying by 2. I'm straight away multiply by minus 2, so that makes it negative. So if I add this cancels out. Minus 8b equal to minus 48 and b becomes minus 48 divided by minus 8, which is 6. And this equation was a plus b equal to 10. So now we can substitute b here. A plus b, which is 6 now, equal to 10. That gives us a equal to 4. We got a equal to 4 and b equal to 6. Additionally, they said Hence, find the coordinates of the center of the circle. And center of the circle are negative half of the coefficient of x and y. And coefficient of x is 4. What is negative half of 4? Which is minus 2. Negative half of 6 is minus 3. So the coordinates of center are minus 2 and minus 3. Done. Here is the next part. Find the equation of the tangent to this circle, okay, at the point A. Point A is 1, 1, okay. Giving your answer in the form of P plus Q, K, Qy, Px plus Qy equal to K, alright. So, if this is the circle and this is 1, 1, where it is the tangent, we have to find its equation. The easiest one is that we know that center is minus 2, minus 3 now. We can find the gradient of this radius, and we know the radius and tangent at the same point make a 90 degrees angle all the time. So we can find the gradients of this and we can find the equation of that line, this one, tangent. Alright, so let's find the gradient of, this is O, center, this is point A. So OA will be y2 minus y1 over x2 minus x1, 4 over 3. That means gradient of the tangent will be negative reciprocal of this, which is negative 3 over 4. Why? Because it is at 90 degree. The perpendicular gradients are like this, negative reciprocal of each other. Now the equation of tangent equal to y minus y1 equal to mx minus x1. Y and x are random points, so we will not change them. Random coordinates of a point. Okay, so y minus y1 point, specific point on the line is 1 and 1, so it will be 1 here and 1 here, and gradient we just found out minus 3 over 4. And just cross multiply this 4 here and 3 minus 3 with this, you'll get it. 4y minus 4 equal to minus 3x plus 3. Let's complete it here. Bring 3x on the left side. They want k, the constant, to be on the right side. So 3x comes to the left side, becomes positive. 4y is already there, equal to 3 plus 4. So 3x plus 4y equal to 7. This is the equation of the tangent to the circle. Question number 9. The equation of a curve is this thing where x is greater than negative 1/3, and we have to find the first and second derivative. Let's find the first one. Dy over dx will be differentiation of 3x is 3, differentiation of 1 is 0, and differentiation of this linear with an exponent is minus 4 is a constant, so it remains. The exponent comes in front and the exponent goes down by 1. Now further we have to multiply by the differentiation of what is inside the bracket, which is 3. Differentiation of 3x plus 1, 3. So we get 3 plus 6. First of all, this and this cancel out. 2 and 2 times 3 is 6. And 3x plus 1 to the power half minus 1 minus half. That's the first derivative. Second derivative. Derivative of 3, 0. And same thing happens with this one, which is minus half comes in front. And then we have 3x plus 1 to the power minus half minus 1. and we multiply this further by the differentiation of contents of bracket, which is just 3. So we get this and this cancel, and this negative will make it negative. So minus 9 3x plus 1 to the power minus 3 over 2. That is the second derivative. Okay, let's talk about the next part, which is this. Find the coordinates of the stationary point of the curve and determine its nature. To find the stationary point, we equate the first derivative equal to 0 because it is gradient, and at stationary point the gradient is 0. So let's do B part here. 3 plus 6 3x plus 1 to the power minus half equal to 0. So we can keep this 6 here. 3x plus 1 to the power minus half equal to negative 3. Yeah, this 3 goes to the right side, becomes negative. Okay, so let's continue it here. So divide both sides by 6 and 6. So 3x plus 1 to the power negative half equal to minus 1 over 2, because 6 and 6 cancel here, and minus 3 over 6 is negative half. So to get rid of this negative half, to focus on x, we will give the whole of it a reciprocal power of this one, which is minus 2. So same we have to do to the other side also, power minus 2. So this minus half and minus 2 give it positive 1, so we are left with just 3x plus 1 here. And to make this negative positive, we will reciprocate the 1 inside, which is 2 to the power 2, or rather negative 2 to the power 2. Alright, and 3x plus 1 equal to 4, and 3x equal to 4 minus 1, which is 3, so x is equal to 3 over 3, 1. The 1 is greater than what they had given, negative, x is greater than negative 1/3, right? And our answer is greater than negative 1/3, so this is correct. Second part is find the nature of this particular point when x is 1. So for nature, we take help of the second derivative, which is this. So for nature now, where x is equal to 1. So we'll substitute x equal to 1 in our derivative, second derivative, which is 9 3x plus 1 to the power minus 3 over 2. So minus 9 3x plus 1 to the power negative 3 over 2. So this is d square y over dx square. So minus 9, 3 plus 1 is 4. And let's write 4 first. 4 to the power negative 3 over 2. And let's continue here. Minus 9. We have to reciprocate this to make it positive. So it becomes positive 3 over 2. But the contents reciprocate. So it will be 1 over 8. Minus 9 over 8. This is the value of second derivative when x is equal to 1. And whenever it is negative, negative means it is opening down. If a curve is opening down, it can have only a maximum where the gradient will be 0, and this is the maximum point. So x equal to 1 is a maximum. Right? Now, they're saying determine its nature. Coordinates, we have to stationary, we have to find coordinates. We know only x coordinates. So to find y coordinate, we'll take the help of the main equation. What is the main equation? Equation was y equal to 3x plus 1 minus 4, 3x plus 1 to the power half So we'll substitute x equal to 1 into this and we'll get the full coordinate y as well. So 3 times 1 plus 1 minus 4, 3 times 1 plus 1 to the power half. So 3 times 1 is 1, 3, and 3 plus 1 is 4. 4 minus, and this is 4, square root of 4 is 2, so 4 times 2 is 8, minus 8, which is equal to minus 4. Y coordinate is minus 4. So coordinates of maximum point are 1 and negative 4. What do you have next for us? Question number 10. The function f and g are defined as follows. We can see that, okay. Fx is this, gx is this, they have their own domains. Okay. The diagram shows parts of y equal to fx only, okay. State the domain of f inverse. So domain of f inverse will be same as range of fx, but it is the value of x, this will be the value of y. So let's say what is the value of y which is there. So all values we can see, this is the graph in y's direction, every point is there except for this one which is x equal to 1, and we have all values below x equal to 1 also. That means the domain of the range of fx will be fx cannot be equal to 1. That is the only number where it is not having any value. X cannot be equal to 1. The range of fx is the domain of f inverse, but this was y, this is x. B part, find the expression for f inverse x. So first of all, let's copy what is fx, which is 2x plus 1, 2x minus 1. 2x plus 1, 2x minus 1. Okay, so to write inverse of this, we exchange the values of x and the places of x and y. So it will become x equal to 2y plus 1 over 2y minus 1. Let's continue it here. Cross multiply first. So 2xy minus x equal to 2y plus 1, and now our purpose is to isolate y, make y the subject, so y should be on the left side. 2xy minus 2y equal to x plus 1, take 2x minus 2, y equal to x plus 1, so y taken common here. So by cross multiplication again, y equal to x plus 1 over 2x minus 2, and we can write this as f inverse x is x plus 1 over, we can take 2 also common here, so 2x minus 1. This is the inverse of f. Okay, next, find g f inverse 3. G f inverse, this is how we can write this as. So let's write f inverse 3, what is inside the bracket now. So here we will put 3 in place of x because we have f inverse x here. So 3 plus 1 over 2, 3 minus 1. 3 plus 1 is 4, 3 minus 1 is 2, times 2 is 4. So f inverse 3 is equal to 4 over 4, 1. Now, we have to substitute this into g. That will make it g f inverse 3. So g1, because f inverse 3 came out to be 1. And gx, what was the expression for gx? It was x square plus 4. So it will become 1 square plus 4, which is 5. Explain why G inverse X cannot be found. We can't find G inverse X, okay? We can see, what is G inverse X? G inverse X what is Gx? So Gx is x square plus 4. It's a quadratic, right? And if I draw the graph of x square plus 4, it is something like this, plus 4. That means it is gone up by 4. This is how the graph of x square plus 4 will look like. And we can see here that two same level of y. This is y level, right? This y belongs to two x's. This is one x value and this is second x value. Two x's have same y. So we will say that it cannot be found because it is a 1 to 2. 1 to 2 function. What does that mean? That one y has two x's, and for an inverse we need 1 to 1. So the inverse will not be 1 to 1, right? And 1 to 1 is the primary, which is the primary requirement for an inverse. If two y's have one x, that is not a function, but its inverse will exist. But here this is a function which is 1 to 2, and that's why it will not have an inverse. All right. Show that 1 plus blah 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 can be expressed as this. Okay. So let's rewrite 1 as 2x minus 1 over 2x minus 1, and we already have 2 over 2x minus 1, right? This one is written, but 1 is written as this so that the denominators are same, and we can combine the two expressions to make one rational expression. So 2x minus 1 is the denominator, and numerator becomes 2x minus 1 plus 2, and 2x minus 1 plus 2 is 1. So 2x plus 1 over 2x minus 1, we've shown this. Let's find what is the second thing. Hence, find the area of the triangle enclosed by the tangent to fx at point x equal to 1 and x-axis and y-axis. So we need this is 1 x equal to 1, so somewhere like this. It is coming at 2, but we are not sure if it will be at 2. So this is the area we need. This area between the tangent, y-axis and x-axis. So we have to ensure that this 2 and that number up there are actually correct. I may have drawn it that not that well, that's why I'm not confident about this too. So for finding this x-intercept of the tangent and y-intercept of the tangent, we first know what is the equation of the tangent. So let me use this space. Equation of tangent is y minus y1 equal to mx minus x1. All right. So y1 is not known to us, but x1 is known to us. The line point on the x coordinate is known to us for this point. What is the y coordinate? Let's use the formula. This is the formula for fx, right? This is this one, 2x plus 1, 2x minus 1. So I will find y here. Let me find y. 2 times 1 plus 1 over 2 times 1 minus 1. So it will be how much? 2 plus 1, 3. And 2 2 minus 1 is 1. So the y coordinate is 3 and it was known to us here. Can you see? It was 3, but we have to confirm 1, 3 is the point. Alright. So we know the y also now. So we can substitute them in the equation now here. This is 3. This is 1. We don't need this yet. And this also is not needed. What we need is m. Okay. So to find m, m is the gradient. We will use this one to differentiate. We'll differentiate this and we'll get m. So the differentiation of 1 is 0. So dy over dx equal to 0 plus, and if 2 over x minus 1, it can be written something like this. Let me write here 2x minus 1 to the power minus 1. Isn't it? This was a denominator, I made it a numerator. So I'm going to differentiate this one. 2 is a constant, minus 1 comes in front, 2x minus 1 to the power minus 1 and subtracted minus 1 again. And further we have to multiply it by the differentiation of the content, which is 2. So we get minus 4, 2x minus 1 to the power minus 2. So now at x equal to 1, what is the gradient? It will be minus 4, 2 times 1 is 2, minus 1 to the power minus 2. So 2 minus 1 is 1 to the power minus 2. Anything power 1 is 1. So overall it is minus 4. We got the gradient equal to minus 4, which was the only missing thing here. Minus 4. So the equation of the tangent is y minus 3 equal to minus 4 x minus 1. It is already written, so we don't need this. Now, but our purpose was to find x and y intercept. Let's find and confirm if x intercept is 2. For x intercept, y has to be equal to 0. So let's write x intercept. So 0 minus 3 equal to negative 4. X is, we don't know, but we want to find out. Okay, so minus 3. Minus 3 equal to minus 4x plus 4. So this plus 4 goes with minus 3, becomes minus 7 equal to negative 4x, and x is positive 7 over 4 because negative and negative cancel out, and that makes sense, and it is not 2. It is little lesser than 2. Okay, so the drawing was random and this 2 was not right. It's good that we did not believe our drawing. Okay, let's find the y-intercept. Where is this crossing the y axis also, so that we get the height of this triangle. So let's put the same here, but for y-intercept, x is 0. So y minus 3 equal to negative 4, 0 minus 1. So y will stay here, minus 3 can come here. This is how much? Minus 4 times minus 1, positive 4, plus 3. 4 plus 3 is 7. And that makes perfect sense. Here it looks like it is 5 or 5.5, but as I told you, the line was, the tangent was drawn randomly. This is the right one. So we know now this length, which is 7 over 4. We know the height also. We can find the area of the triangle now. So area of triangle will be half base times height. So 7 times 7 is 49 over 8. Are they saying exact area? Let's see. Okay, they have not specified, so you can write this, or you can convert it to decimal, which will be 6.125 units square, and 3 significant figures will be 6.13. Let's move on to question number 11, the final question. The function f is given by fx equal to 4 cos to the power 4x, and this, okay, between 0 and 2 pi, given that k is 3. So they have given k equal to 3 for the first time, so we can use it. 4 cos 4x plus cos square x minus 3. This is our k replaced here, and they said find the solution, exact solution of this equal to 0. So we can see that it resembles a quadratic equation, but it is not exactly quadratic. So let's assume cos square x equal to t. So cos square x, this will become 4t square minus plus t minus 3 equal to 0, and we can find the values of t now by factoring. 4t square plus 4t minus 3, t minus 3 equal to 0, 4t taken common, t plus 1 minus 3, t plus 1. So we get two factors, 4t minus 3 and t plus 1. So this gives us 4t minus 3 equal to 0. So t comes out to be 3 over 4. This gives us t equal to minus 1. Okay, this we can negate straight away. Why? Cos square x was the actual one, equal to negative 1. A square number cannot be negative, right? So that means this answer is inadmissible. We will not at all use this. That means we have to use this one, and we'll use it here. Cos square x equal to 3 over 4. Square root both sides. So cos x equal to plus minus square root 3 over 2. Plus and minus both, and we want from 0 to 2 pi. So we know that all four quadrants from 0 to 2 pi, here the cos is positive, here cos is negative, and cos is positive. So because we have both options, positive and negative, all four quadrants will have the answer. For that, we need to find first what is x equal to cos inverse square root 3 over 2. Let's find it, and I already know this. This is pi over 6, 30 degrees, pi over 6, and that means we will write pi over 6 in all four quadrants, the acute angle with horizontal line, and this will give us our answers. Let me write them one by one. First answer, from 0 we start always. This is the first answer, which is pi by 6. So the first answer is pi by 6 itself. Second one, we'll move further and go to the second line here, which is pi by 6 less than pi. So it will be pi minus pi by 6, which is 5 pi by 6. This is the second answer. X3, go further to the next line. It is pi by 6 more than pi. So pi plus pi by 6, 7 pi by 6. And finally, we have fourth answer, which is this line, which is pi by 6 less than 2 pi. 2 pi minus pi by 6, which is 11 pi by 6. These are the four answers of the given equation in part A. Let's go to part B. Use quadratic formula, alright, to show that k is greater than 5, the equation fx equal to 0, when equation fx is equal to 0, and if equation fx was 4 cos to the power 4x plus cos square x minus k equal to 0. So let's see if I've written the right one. Okay, that is correct. Now, if we use quadratic formula, we first look at discriminant, and we want no solutions. So b square minus 4ac, right? It has to be less than 0. And look here, b is 1 for us here. 1 square minus 4 times, and k, they have given more than 5, but let's write it minus k. We can't say that it is that way, but if we'll, this will definitely give you an answer. 1 plus 16k less than 0, not 5, less than 0. So it will somehow give you an answer, but this is not actually they want the cos square should not have an answer. So we cannot use discriminant in this. That's what I try to explain to you through this activity. So we will use the quadratic formula because they have already hinted here, use quadratic formula. So we will use it now. Minus 1 plus minus square root 1 square is 1 minus 4 times 4 and no minus k over 2 times 4, and this is cos square x. This is the value of cos square, whatever we are getting here. So let's see what we are getting here. Oh, minus 1 plus minus 1 plus 16k, the discriminant we were getting here, over 8 equal to cos square x, right? Now let's leave it here and think about cos square x. Cos x, what is the form, what is the graph of cos x? It is like this. It is between 1 and minus 1, correct? Cos x has this graph. So what will be the graph of cos square x? So that means it will get squared. Every value will get squared, right? So square of 1 is 1, right? A square of any value less than 1 will be smaller than that. So it will basically little like this. But the negative part will also be square to positive. So we will have a graph like this, and we already have a graph. So let me again redraw this. The graph of cos square x, y equal to cos square x, will be something like this. That means the maximum value is 1, the minimum value is 0 now. It means there are two situations. First situation is minus 1 plus minus square root 1 plus 16k over 8 cannot be, will not have any solution for less than 0. Can you see? Less than 0. That is one condition. Second, minus 1 plus minus 1 plus 16k over 8 cannot be more than 1. These are the two situations when there will be no solutions for the given quadratic equation. So let's solve them one by one. 8 multiplies with 0, 0. So minus 1 plus minus square root 1 plus 16k is less than 0. We can bring minus 1 there. So plus minus 1 plus 16k is less than 1. Let's square both sides. So this left side will become positive. Doesn't matter plus and minus because of square it will be 1 plus 16k is less than 1, and 1 gone. So 16k is less than 0, k is less than 0. K cannot have a value less than 0. If it has, there will be no solution, but k less than 0 is not in what they're asking. They're asking us show that when k is greater than 5, the equation has no solution. So maybe this one will give us k greater than 5. They're not telling us that k greater than 5 is the only one where it has no solution. It is k is less than 0 also. So let's do the same thing here also. 1 plus, so minus 1 plus minus, okay, plus minus square root 1 plus 16k is greater than 8 plus 1, 9. Okay. So square both sides again. So 1 plus 16k is greater than 81. 16k is greater than 81 minus 1. 80, and yes, divide both sides by 16, positive 16, so does not change any sign. K is greater than 5. Yes, this one proved that K cannot have a value greater than 5. If it has no solutions.